This time I have a Breville convection smart oven, model number B0V800XL/A. Hi guys, I got another one of those Breville smart ovens in. This one here, apparently the heating element on the bottom doesn't work. I'm just going to verify that they're not getting warm. The heating element on the bottom is not heating up whatsoever. Feel heat from the top, nothing from the bottom. Okay, so worked on a couple of these before. I have one just like this. This one was brought into me to take a look at. Don't know if I'm going to be able to fix it or not, but gotta start somewhere. I'm going to look at the control board, because if you guys remember from when I worked on my own, there's a control board on the side here, and mine had the fan. Mine's got a bad fan, but there's a control board on the side. And when I looked at another one, it was completely dead. Solder connections had broken on the control board. I've worked on two of these before. Anyway, now I know how to take them apart. They're a pain in the butt, but because there's screws in the front that are hard to get out. But we're going to open this one up and check that control board. It's either going to be a failure on the control board or a failure of the element. There's not really a lot else that can go wrong. But the person that owns this one wants to spend money on it, because these are not cheap, right? These units here are a couple $100 to buy a new one. You know, and the newer one, they got an even newer one. I think it's got air frying, which is even more money. But people that have these ovens just absolutely love them. I know that the one that I have, it gets used every single day. Not a day goes by that it doesn't get used, and everybody I know that's got one of these feels exactly the same way. They're just fantastic. You know, some people call it a toaster oven, but it's not. It's actually much more than a toaster oven. It's a convection oven is what it is. So let's get the screws out of the side so I can get the cover separated. So the screws need to come out from the base. Use a screwdriver for these ones because the holes are a little too small for the larger bit to go in, so I'm using the smaller #2 Phillips. Get the last two screws out, and then this bottom cover will lift off. That has to come off because there's screws underneath here that need to come out as well. Now these edges are sharp as a knife, so you gotta be careful when you're working on these because you'll get cut real easy. Nothing has been filed off or anything. They've just all been cut with a punch press at the factory, and they're like a knife. Now comes the fun screws. There are screws that are in the cabinet here that you take out. You need a long screwdriver to get to them, but there are 3 screws in the side here that need to come out. I want to try to disassemble the least amount of this as I have to. In other words, I don't want to take the whole top cover off because it's a real pain to get it back together. Okay, I've got the 2 screws or the 3 screws from the side out. Now I've got the cover enough off that I can probably get the board out. I want to lift the board out and inspect for any bad connections that may have occurred on this board, and then of course at that point I can also check the heating elements to see if they're open. The circuit board is held in place with a couple screws, so I'm just going to remove those screws so that I can inspect the board. Your hands do get all scratched up when working on these things. I've just unplugged the lower heater. This is the lower heater element. We can check that first of all and see whether it's got continuity, because if it doesn't have continuity, then there's no point in going any further than we are. But if the element itself has continuity, then we know that the heating element is not failed. And as you can see, 17 ohms tells me that the heating element is good. So we know the problem is going to be on the board. So I've got it unplugged now. I've got the low voltage transformer unplugged, and I've got the data plug, or the control board, unplugged. With the screws out now, I should be able to lift this board out. I should have enough clearance now that I can lift the board out, and we can look and see if there's any connections that have burned away on this one, like happened on the last one. As we can see, this connection here looks to be in pretty sad shape. This one is burned right open, and that just happens to be the one right there. If we notice where that goes, it's going to a relay. That is going to one of the terminals for the lower heating element right there. That connection has burned open. So I'm going to resolder this board, and I bet that's going to fix the problem. And I can also see that these other connections down here also need to be done, because they haven't failed yet, but you can just tell from how dull this looks that these ones are the very next ones that are going to fail. So I'm going to redo all the connections on here, all the high voltage. Oh, this one here is also, look at that one, right? That's the main power input for the heating elements. It switches between the high and the low with this relay. So this is the common terminal. So anyway, let me get the soldering iron warmed up, and I'm going to try to not destroy my hands any more than I already have, because I tell you, these things are just murder to work on. They're so sharp. Now these ones are carrying the full current, and this is rated 1800 watts. So this draws 15 amps, and it draws that complete circuit. When I've had mine running on full power, if you try to run anything else, you plug a 100-watt light bulb into the same circuit, it's going to pop the breaker. These were heavy-duty units that draw the maximum power on a 15-amp circuit. It's actually preferable to have them on a 20-amp circuit in your kitchen, but they don't require a 20-amp circuit. They have a conventional 15-amp plug, as you can see. But they do draw the full load, and they cook wonderful. I think what this relay does is it switches between the bottom element and it's not actually, I don't think it's between the top and the bottom. I should look and see where the wires go. But I think it's actually between the bottom and the center element, which is used for broiling, is what this relay is for, if I'm not mistaken. I'll just take a look and see. Yeah, that's what this is. This is heater mid. Heater top is over here. So this relay here selects between the bottom elements, and on this one there's 5 elements. There's 2 on the top on either side, there's 2 on the bottom on either side, and then there's a middle one which is used for broiling. And when you're broiling, obviously the bottom elements aren't heating up. So this one here selects the broiling element. This relay is what that one does. That's what that's on. I will resolder the lugs as well. Oops, Well, that one fell off. I'll have to go and retrieve it. Let's try not to make the next one fall off when I heat it up. These are tracks that control the power. Right here. They look okay. I think that's pretty much got all the connections that have failed on the board. So now time to start to reassemble and hack my hands up a little more. Ouch. Now be sure you get, there's a mica insulator that goes underneath the circuit board and it's held underneath these two screws. Just make sure that you get the mica insulator lined up, because that's what insulates the high voltage from the board from being in close proximity to the ground of the cabinet. We want to make sure that we get the mica insulator in place, which I've got in place. Now I just have to screw the board back down on all four sides. Now time to reconnect the connectors I took off. The heating element low goes there and the other one goes over here. And then there's the timer plug and the power plug for the low voltage transformer. And then I got to get some zip ties and tie these wires up out of the way again so that they're not going to get stuck in the fan. All the wires are tied up. They're away from the fan. Nothing going to make any contact with the fan as it spins. Now I can start reassembling and test. Actually, I'll test it before reassembling, but I know it's going to work. Yeah, I'll turn it on for testing. See if the bottom element heats up. Wasn't getting hot at all before. Yeah, I can feel the heat coming off it already. It's getting warm. Put the camera in night shot and you can see how hot they're getting. Turn it off and they should start to cool down. There it goes. Getting hot. Getting real hot. If I turn off the night shot, we'll actually see the thing start to get red as it starts to get hotter. There we go. See? Bottom element's now working like it's supposed to. And off. Now I gotta let it cool before I put it together. Perfect timing. The workshop's up to the temperature. The heat went off. I got a 4.8 kilowatt heater that warms the place up nicely when it's cold. The toughest part of putting this thing back together is getting these 3 screws on the side that hold the front in place. That's one of the hardest parts, and then this top cover slides into place. Once I get that in place, that'll pop in like that and close in like that. But so this is the hardest part of this design is getting these screws in. So I won't run the camera because there's probably going to be some bad words said. Okay, the first 2 are in. I guess I might not be cursing quite as much for the last one because it's not a problem to get in. But the other 2 were certainly, they were certainly fun to get them threaded, I'll tell you. Look, I didn't even dent it. Excellent. Alright, now I gotta get the back cover. That's another fun piece. Because it goes, this lip goes inside the back on this side, but on the outside on the back. So yeah, this is always fun. Lots of fun. Back cover is on. A little dent here. I'm trying to straighten that out. Oh well. That goes on like that. 2 more screws to hold this in place, and then the 4 on the feet, and this one is all done. And believe it or not, you guys might find this hard to believe, I make more money fixing an oven like this. Whoops. I make more money, I'll get the other screws in first. I make more money fixing an oven like this than I would fixing a television. Believe it or not. Like, this is a $250 oven. And I'll make more on this than people will spend on a television. Go figure. Same with a microwave oven. If I fix a microwave oven, I make more money fixing a microwave oven than I do on a television, and even a tape deck or audio components. Doesn't make any sense because this is a cheap kitchen appliance. But people will pay more to fix their cheap kitchen appliances than they will for entertainment products. Of course, the only downside to working on things like this is when you're done, you got to go see your doctor and get a tetanus shot. Man, they're hard on the hands. They're cut like a knife.
Thanks for watching.